Just make sure you don't forget.
Okay.
Oh. Try again, take two. I have the other notes ready. Worst comes to worst. Actually, I have the other notes ready just in case. That's right. I did that for a reason. Alright, ready? Let's see if I can get it back. So you guys are sad. Yeah, go back. Okay, good. Some more techniques for limits. At the very, very, very end of section 12.1, the most favorite, well, hopefully, your preferred way of finding a limit was the plug-in and chug-in way, otherwise known as direct substitution. True. Weren't those the easiest problems in the limit? We spent like 2.5 days on section 12.1. And then the last, was it 60 seconds of class? We did 6 limit problems. How is that possible? Just plugged in. But the limit is just plugging in. Doesn't always work. And we're not necessarily going deep into the theory. We talked about the limit as x approaches a in this case. Now they've changed the letter to C. It doesn't make a difference. It's a constant. It's just the place x is approaching. They're saying direct substitution is great if it works. And it's great for well-behaved functions, aka functions not their discontinuities. Basically all functions not their discontinuities besides piecewise. Piecewise are not well-behaved. Yes. But it could, you probably could just fit it in next to it. You probably could just fit it in next to it. So to be honest, even though I'm going to show you all sorts of different techniques, and I've numbered them just so that you have different ones in your heads, basically, they're normal algebraic functions. So let's say non-piecewise functions where plugging in works. Non-piecewise functions where plugging in doesn't work, and then piecewise functions. Those are the 3 categories. Non-piecewise functions where plugging in works, non-piecewise functions where plugging in doesn't work, and then piecewise functions. Those are the 3 categories of functions that we would be required to algebraically simplify. Ella and just put it in class. Coach Stacy? Mr. You just call him. Sheldon. Many athletes do. You guys just ignore it. Oh, so that's why you didn't know what I said starting. Yeah. Alright, you guys got it written down, okay? Okay. And is that Colin's question?
Oh, this is Sarah's.
I was like, wait a minute, that can't be.
Yeah.
It's like, we put it on. Alright, kids. Let's go ahead and go back to the evening so that we can check. I think everybody's settled. Everybody has their notes out. Hopefully homework finals are close. Direct substitution was number 2, which was hopefully your favorite way of solving the limit from section 12.1. The tables took a while, but they were really, really important, even though you guys thought that was so annoying. They were really, really important for getting the idea down of a limit, in that a limit is talking about what a function or how a function is behaving as x approaches. Once again, not necessarily at. So if you guys notice in every single one of these tables, there was a 2 with a question mark, a 2 with a question mark, a 1 with an error. The point was not necessarily what was going on at A, but the approach instead. So, but number 8 was supposed to be 1/3. They didn't do this extra, the limit is not reached. That's just them saying 1/3, but if you plug in, it doesn't work. Number 16, that one was really funky because you're like, what decimal is that? Long story short, it's okay, don't stress. We're going to learn another way of solving this anyway. But the final answer is -1/16. If you guys got this funny decimal of -0.062 something, check out -1/16. That's the decimal, and you'll see it. You'll see the similarity and the resemblance. Once again, we're going to learn a better way of taking that. The table you're just kind of exploring. And then number 22, the final answer is 2. Once again, the limit's not reached because if you try plugging in, it doesn't work. That doesn't mean we can't solve it. We just need section 12 too. So we got to get there. Number 28. Do they have you using a table or a graph in 28? Oh, you're using a graph. Okay. Long story short, as you come from below and above, the one-sided limits do not agree. From one side it looks, now some of you might not have paid attention, but one side it's going towards a positive one, I think that's from above, and from below it's going towards a negative one. Remember, if the one-sided limits do not agree, the limit does not exist. Number 30, the limit does not exist because f does not approach a real number. Question though, when you guys checked out 30, was there a way that you still could have answered the question? Was it that the limits did not agree? Or was it just that they did agree but they were going to infinity or negative? You guys know that there's like decimals or online graphing calculators? If you have a basically a non-Apple device, there's even like a really cool, basically, illegal app on graphs where there's like a graphing calculator. Silly Apple and all their like, trying to be legal. Anyway. And number 30, I disagree with the book. That is not why the limit does not exist. Let's see if you guys can find out. If you'd written this, just written a copy on one, if you have anything else. Question. It's not about f of x going to infinity. That's not the reason for it. We can still write like infinity and negative infinity and answers, and that's okay. Why does the limit not exist in number 30? It's not about it not defined. I like what I was hearing in the back. They're not approaching the same direction. They're not approaching the same. Now, you can't say constant, because you're right, there is no constant at 1. There's a vertical asymptote at 1. But remember, it's not about what's there. It's about how the function is moving towards that point from below and above. And as I go from below and as I go from above, function is going down, function is going up. Because f of x approaches, I guess there's one more saying it. Different directions. Can I say that? Different directions. I'm not going to say different values because infinity is not really a value. I'll say different directions from below and above. Another way of saying it. Different directions from below and above. Another way of saying it would be that the one-sided limits do not agree. They're going different ways. I disagree with the book's reasoning on that. You guys can already see number 34, that's ln of 8. Number 40, That was just from substitution. Number 42. You guys were just using properties, and hence how you were able to get 9 to negative 60, negative 1 half, and square root of 5 over 5 after rationalizing. Number 38. Look at that. The functions are going two different ways. No, the limit does not exist. You can be super snazzy and talk about from below. They say from the left, same thing. From below, from the left. The function is going to positive infinity, and from the right, from above, the function is approaching negative infinity. Last but not least, plug it in, plug it in, plug it in. Ew, don't do the decimals. You kind of free. So much nicer. Alright, if you guys are done with homework files, go ahead and put them away. Notes open. Were there questions on any of the evens and or the odds as far as the ideas, as far as the working out, as far as the solving? Is he the only even that we were missing? Was he a function? Was he a graph? Was he a word problem? I think I should have left this out. A brief description of the meaning of the notation. Just translate it. The limit as approaches 5 of f of x is 12. You could also say something to the effect of the limit exists as you come from either side of. Does that make sense? You could say something like the y values are approaching 12. But for the sake of argument, I'm going to say answers vary. That's a good cop out, right? Other words, use cop out is something that's like to duck out of it, to avoid, Anyway, number 65. Here goes. You don't have to write this down in your notes. Instead, I just want you to think about it. I know the quality is really bad. It was back before I had like these PDF scanners and all this jazz since the apps on my phone. But that's alright, we can still deal with it. True or false? The limit of a function as x approaches c does not exist when the function approaches negative 3 from the left and 3 from the right. Don't answer out loud. I want you to think in your mind. You're going to vote for either true or false. And if you don't vote, I'm going to publicly humiliate you and make you stand. So, read the question and actually participate. You are going to answer true or false. The limit of a function as x approaches c does not exist when the function approaches negative 3 from the left of c and 3 from the right of c. The limit does not exist as it approaches negative 3 from the left. How many of you guys say true? The limit does not exist. How many of you guys say false? So, ready? What if from below, f of x approaches negative 3. From above, f of x approaches positive 3. Why was this true? Someone who gave that answer, tell me why.
For there to be a limit that is correct, they both have to be approaching the same number.
So from notes from Friday, before we watched the Mean Girls clip, we were talking about D&E. We approach from either side, and they result in different answers. The limit does not exist. Right? So this case was different answers. You had negative 3 and you had positive 3, but once again, thank you everyone for listening. Since, as you come from below and above, they are approaching two different heights, the limit does not exist. How about number 72? How do you see it? Can you see it? Okay. I have a function, it's just the graph. I don't know who he is, he's just F. We'll just call that X. Who can raise a hand and give me an answer for what would be the value of f of 0.
One.
Function value at x equals 0. Sean? Yes. 1. Okay. Who can give me the limit as x approaches 0 of f of x? When x approaches 0 of f of x. Why? Good. Sean, what would be the limit as I come from below x equals 0? Good. As I come from below, the function is headed to 4. Doesn't matter what's there, it's still headed to 4. As I come from above, doesn't matter what's there, the function is still headed to 1. Those do not agree. Two different paths. Letter C. What's f of 2? Someone different who hasn't participated yet. What's f of 2? What do you think is that? Never mind. You might be right. Brandon.
Oh wait, no, does it not exist?
So what does that mean about the function value? The function value does not exist. It's okay, we're just getting things straight. Brandon, yours was good for the limit. It's approaching 3. What answers the question of approach? Limit. But what answers the question of who's actually there? F of x. So f of 0, remember what was actually there, and it's where the filled in point was, which was down here. Right? But the limit says, well, what was going on either side of it? And f of 2, what was going on actually there? Well, nothing. It's gone. The limit, though, what's going on either side? Questions about ABC? Anyway, that's in the notes if you guys want that. Let's go and go back to section 12.2. Section 12.2 says exactly where. Section 12.1 ends. 12.2 picks up exactly where 12.1 ends. Meaning, there might be some limits in homework where you can just plug it in, be done. Plug it in is for non-piecewise functions, or piecewise functions not at the separator between the inequalities. Well-behaved functions, or well-behaved pieces of functions. Plug it in. If it works, golden. If it doesn't, let's start thinking about some other strategies. What if direct substitution, you try plugging in, and you get 0 over 0. Write it. 0 over 0. If you do 0 over 0 in your calculator, yes, it does not exist. But that's what's going on at the point. And remember, we're not necessarily worried for a limit of what's going on at the point. Okay, fine, something messed up at the point. There's an error. Something doesn't exist. The value, the y value doesn't exist. But what's about the limit? If only there was an algebraic way, so we didn't have to get out our vacuum calculators. We didn't have to get out a table. And there is. I need you guys to go ahead and say, if you ever get keep 0 over 0, I want you to literally write, keep going. If you want, you can make a page. Keep going, not kilograms. Keep going. For a limit, if you ever get 0 over 0, keep going. That is not an answer. That is not a DNE. That is not necessarily hey, keep looking, there's an answer out there. We don't know. For a limit problem, if we get 0 over 0, that is not sufficient information to tell us what's going on either side of the point. It's enough to say there's an error at the point. So, like the example that we just did, it's enough to say that the function value, like this one, does not exist. But it is not enough to say anything about the limit. So therefore, if we ever get 0 over 0 when plugging in, keep going. One way of keeping going is to use factoring or polynomial division to simplify. Just use factoring or polynomial division to simplify. As we're going to start playing this in algebra, there's a lot of it this lesson. But some of you are like, put it in the calculator. Right? Disgusting tables. Okay. Step 1, write the example. Step 2, it's a limit problem. Step 3, just kidding, those are all like just how to start. Getting to where you solve. First thing you can always try, if you're trying to solve for a limit, and it doesn't say you have to use a table or you have to use a graph, say, it was so nice in 12.1. Plug it in, plug it in. And when you plug it in, let's see what happens. Some of you would see that denominator and say, it's over 0, DNE. As you simplify, 9 minus 3 is 6, and 6 minus 6 is 0, and here's where the funny stuff happens. Believe it or not, this is very important. And I will take off points on any quiz, any test, and maybe even any homework where I do not see this being done. But plugging in, figuring out whether you've arrived at an answer and can stop, or whether you've arrived at 0 over 0. And if you've arrived at 0 over 0 and you're lazy, you can write kg. Or you can write the entire keep going out. Whenever we see 0 over 0, we're going to write keep going. And if you're too lazy for that, that's okay. Kg, or like kilogram, but not. Keep going. If you don't write it, I'll take off points. If you don't write something denoting keep going, I'll take off points. Keep going. Why? We're not done. We've just gotten to, okay, I don't think the function exists there. There must be like a hole or a vertical asymptote or a jump or something wrong. We don't care for the limit. The limit's what else is going on around. So we say, okay, let's mathematically try to rewrite this function that's exactly the same except at -3. How can we rewrite this function so it's exactly the same except at -3? Because we don't really care what's going on at -3. My idea from the last page said try factoring or polynomial division. Most of us hopefully, if it's a nice factoring problem, would rather factor. How can we factor it out? That is a -6, that has to be 1. You do x plus 3 and x minus 2. If there are polynomials on top and bottom, 0 over 0 almost always means there's a shared factor that you're going to be able to cancel. We've learned in the past, we've been taught in the past the shortcut, hey, that's a hole, and it's right, it is a hole. We've even learned, hey, factor and cancel out, figure out who the hole is. The point is, yes, there's a hole. But the rest of the point is, even though there's a hole, the limit still exists. We cancel out and we say, now plug in. So try to plug in. It doesn't work. But keep going. Okay, let's try factoring. Hey, that works. I canceled out something. I canceled out the something that made the 0 on the bottom that made the mistake in the first place. So now what am I going to do? Go back to step 1. Plug in. -3 is x minus 2 because that's all that's left in my function, and my final answer is -5. Just to remind us really quickly of how holes work. What we have right now is a function that looks all messy and rational functionally. This beginning function is disgusting. This beginning function is kind of weird. Okay, so then coming back. The function is messy, the function is really complicated, but doesn't the function look a lot easier now? That's nice too. That's a line. Oh, no big deal. Can we graph a line?
I think so.
Yep. How do we graph a line? mx plus b. Where do we start? -2. We go down 2. Up 1 over 1. How come? Because the slope is understood 1. And 1 means 1 over 1, and 1 over 1 means up 1 over 1. So we go up 1 over 1, up 1 over 1, up 1 over 1. How long are we doing this for? That's good, forever. Okay. How do we go backwards? Down one, back one. Down one, back one. Down one, back one. What did I just do and why? What did I just do and why? Why is there a hole? That nasty quadratic over a linear, x squared plus x minus 6 all over x plus 3 is the exact same thing as x minus 2x. What's going on at negative 3? I have a hole. And where is the hole? What did my algebra tell me? Where was the hole? Negative 5. And what happened when I graphed it? Oh, that is the hole. What's supposed to be there at negative 3? Thank you. Negative 5 is not. So I keep it empty. But here's the question, kiddos. Remember when we were taking limits? Do we care about what's going on at negative 3 or just what's going on as I approach? Exactly. So as x approaches negative 3, looking at the function, my function is approaching a height of, so what is my limit? Got it. So the same way we used to find the hole, that's how we find the limit. Same way we used to find the hole, we find the limit. So that's as hard as today gets.
Really?
No. Oh, you get to just play with equations. Guys, that's all we're doing. We're playing with equations. Well, the only other notes I'm going to do is if I'm like, this one's kind of harder, let me tell you how to do it. And then more examples. This one's, oh, okay, that one's just like if you're totally stuck, use your graphing calculator and see if maybe you shouldn't be totally stuck. Well, that could be Desmos, that could be like Wolfram Alpha, that could be whatever.
So will there be any non-calculated version?
Because I can't have you guys just stay back in the Stone Age and just be doing calculators or your tables.
Okay.
It takes so much more time. It takes so much more time.
That's so more technology. Practicality.
Which is why I did Discovery with Technology. And I had you guys plugging in 1.9, 1.99, 1.99, which you wouldn't have wanted to do by hand. We used the modern marvels of the graphing calculator to build the idea. Yeah, I know, right? Here's are the ones that we have to use. Kiddos! The very first step to a limit is plug it in. Use a table. Yes, you notice how long a table is? You have to put the function into your calculator. You have to go back and delete. Then you have to do 0.9, 1.0. The first step, plug in. What's 1 to the 4th minus 1?
0.
What's 1 minus 1?
0.
Am I serious about the plugging in or else you won't get points? Yes.
Keep going.
But now I'm serious about the either write the keep going or write the KG.
Okay.
Now what do? I don't know. Do something to change this guy. How can I change that guy? Any ideas? Factor out x. That's illegal. No shared x's. X minus 1.
You can't do that. That's illegal.
Square.
Let's divide.
I can do that. If you guys can see the factoring, do the factoring. If you can't see the factoring, off to the side, you're going to say, uh-oh, I don't know what to do, so I'm just going to do the polynomial division because I'm bad at factoring. You can do that. I'll show you how in just a second. But first of all, okay, pause. Actually, I'm going to show you the long way first. Because you guys want to use your graphing calculator. I guess you like the long way. That's cool. X into x to the 4th. X cubed, right? Because some people don't know how to factor. So then we subtract and we get 0. And we bring down 0. Wait a minute. What did I forget?
So negative.
I have to, well, learn how to factor. I have to distribute. So I end up with minus x cubed, right? So then I get minus x cubed, because 0 minus 1 is the negative 1. And then I can go ahead and say, okay, now it's time for me to have, there we go, minus x squared. I'll get negative x cubed plus x squared. That's just a 0, so for him, it doesn't really help. Minus, distribute by the negative. What did I not do in the first one, guys? How did no one catch me? I didn't distribute the negative. Oh, it's such a rookie mistake, and yet it happens all the time. Am I trying to prove a point? I think so. Okay, so then I have to go ahead and, that's still a plus. Gotta make sure all our signs are right. So I go to multiply by a positive x squared. I have a positive x cubed, and I have a negative x squared. Where do we go? All better. That cancels, and I have x squared plus 0x plus x. X squared minus x minus distribute the negative x minus 1. Hey, look, they match. That's cool. Now question, how could factoring have helped us to get there maybe a little bit more simple? How do I factor x to the 4th minus 1? Oh, that's nice. Wait a minute, that doesn't help. I can't cancel anything out. I can factor it again. Exactly.
I'm following, I'm right here.
Exactly. It's saying, look it up. What can reduce? What can cancel out? Now, once I cancel out the denominator, I should try to plug in again. Plug it in, because it didn't work before. But so I got rid of something. Maybe it'll work now. So as I go to plug in, what is 1 squared plus 1 times 1 plus 1? 1 plus 1 is 2, and 2 times 2 is 4. Wait a minute. So what does that have to do with this thing over here, and why do we do it? Question. What is x squared plus 1 times x plus 1? If you couldn't factor, guess what? The polynomial division gets you to the same place. So what you could have done over here on this side is you could have taken this after dividing, and you could have said, oh, hey, that original is equal to the limit as x approaches 1 of x cubed plus x squared plus x plus 1. And if you plug it in, what do you get? Either way you do it, it works. But if you can factor, it's so much faster. It's like before the algebra 1 kids are like, you have to plug that in formula.
Wait.
Because they can memorize factoring if you're not good at it. Which is why you learn how to
So nice.
Alright, come back. But what if there's a number in front? And what if they're not good enough in algebra to even be able to do the grouping without messing up? Hence why you need algebra. Okay, come back. Moral of the story, be perfect. Exactly. So moral of the story, lean on Jesus. Amen. Here we go.
I'm just gonna write that
Don't write just Jesus, because that's not necessarily the answer to the math problem. So you can't say
What is that? Jesus, the answer is
Jesus still loves me. And it'll be like that. Well, it could be the problem, right? But I can say this one Jesus. And then I'll give you candy to say chocolate helps you. Anyway, so. I was partially competitive. Oh, kiddos, did we get it? Basically, I think the quizzes help the chapter 10 test score because you think they're both combined, kind of like they're different scores, but they're 100 points. Overall, I think they help the average. Kiddos, you are writing down what to do. Strategies for finding the limits. Rationalizing. Helpful when I want you guys to underline radicals. When you have radical expressions. And then I want you to underline multiply by the conjugate. This is another time where you get 0 over 0 and you are in the midst of keeping going. So this is kind of like different tricks to try. When you still have 0 over 0 and you're in the midst of keeping going, but you see a radical. My advice to you, multiply by the conjugate. Now, just to prove this to you, we should, of course, always try to plug in 0 plus 1 minus 1, which is 1 minus 1, which is 0. However, it's not a bummer because there's still maybe an answer out there. How do we do it? We multiply by the conjugate. I'm going to go ahead and rewrite, which is what you guys should do in homework anyway. Times conjugate. You guys did this when we were simplifying complex numbers. Multiply top and bottom by the radical numerator or denominator, wherever that radical is. Multiply by the radical expression, but with the opposite sign. Only in between. Only in between. Don't you dare change that radical. It needs to be the exact same. What I do to the top, I have to do to the bottom. Keep it equal. What on earth happens on the top? First, outer, inner, last. Wait, it's a difference of squares. So can't I just go ahead and say this is the same thing as the limit as x approaches 0 of, what's the square root times the square root? Itself. The square root cancels, and I just get x plus 1. The outer would be plus square root of x plus 1. The inner would be minus square root of x plus 1, hence the difference of squares. The last would be minus 1. So I did first, outer, inner, last, but if it's a difference of squares, I just have to square the first, square root goes away, and square the last. Oh, it's a positive and a negative, so it's a minus 1. Then on the bottom, you guys could distribute if you would like. Just a quick hint. What we were trying to simplify was the top, though. So my advice, almost always in these ones, is keep it factored. We multiplied the top, the bottom we kept factored because the top was what was messing us up. That's where that radical was being all messy. Now I have the limit as x approaches 0 of x plus 1 minus 1. Wait, plus 1 minus 1. What happens to plus 1 minus 1? Oh, so it's just x, huh? Why is that nice? What do we have already factored just chilling for us down below? Get rid of that guy. Put a 1 on top. Hey. Back. The x's cancel. They reduce top and bottom. And now I say, I got rid of somebody. I wonder if I can plug in now.
Art.
On.
What is art?
So, if we see a radical, and if we're trying to keep going, what are we going to think of multiplying by?
It's conjugate.
Multiply by the conjugate. Then you're going to FOIL out the part with the radical that you didn't like. On top, you're going to keep back at the bottom and see if you can simplify. So, we're not going to be able to finish this example, but my question just is, after you get 0 over 0, keep going, which is what you get. What would you do to this little guy? Who would you multiply him by?
X plus 4 plus 2.
Plus 2.
Just that? No, say it, just that.
Wait, that's not all.
Oh, that's right. Wait, no. You're gonna mess up like my little algebra 1 kids unless you put your. Alright, now you go. Bye guys. Section 12.2, you're almost done. All of it. Half of it. You do half of it. Michael kids.
Yeah.
Oh, Ryan Murphy decided to put it up there. Technically, you can take any AP exam even if you don't offer a class.
Available as a class member. I wanted to take it.
I know, I wish it was, I really wish, yeah.
Just got here. I'm like,